let us look at Z transforms. Let us see some of the formulas related to Z transforms. Um, that is Z of a UN is written as U bar of Z or U of Z, which is summation n is equal to 0 to infinity un z power minus n. And let us solve a few problems related to Z transforms. Okay, and we have initial value property and the final value property. Let us have a look at that. Initial value property. Okay, that is if Z of un is equal to U bar of Z, then limit Z tends to infinity, U bar of Z is equal to U naught. And the final value property, that is if Z of un is equal to U bar of Z, then the limit Z tends to infinity, limit and is limit Z tends to 1 and Z minus 1 is U bar of Z. Let us look at some of the common functions of Z transforms. Okay, we know that Z of un is equal to summation n is equal to 0 to infinity un Z to the power of minus n, right? So now let us look at the transform of e to the power of n, okay, and also minus a to the power of n. Okay, so let us solve this. Okay, now Z transforms of a power n. Okay, so we know the definition here. So summation n is equal to 0 to infinity an Z to the power of minus n. We have the formula, that is summation n is equal to 0 to infinity un Z to the power of minus n. So here un being a to the power of n, right? So by substituting it, we get this. Now let us substitute n is equal to 0, 1, 2, and so on. So this is a0, this is 0 plus a1 z to the power of minus 1, a square z to the power of minus 2, a cube z to the power of minus 3, and so on, right? And further we can write this as 1. Okay, this part thing is 1, and this is a by z plus a square by z square and a cube by z cube and so on. Okay, Now, by binomial expansion, so this would be 1 minus a by z to the power of minus 1. This is by binomial theorem. Okay. Or we can write as z minus a by z to the power of minus 1. Okay. Or we can write as z by z minus a. Okay. Now, this is what we found for a power n. Now, let us look at when we have minus a to the power of n. Okay. Okay. Now let us change a to minus a here. So z of minus of a to the power of n would be z by z plus a. So we got both the results here. Z of a power n as z by z minus a, and z of minus a n, which is z by z plus a. Okay, we have obtained both these results. Now let us move further by solving these by substituting the value which is a here as 1. Okay, let us take a as 1 here. Okay, so z of 1. Okay, so this is z by z minus 1. Okay, and z as this is minus 1 to the power of n, which is z by z plus 1. Okay, yeah, suppose we have constant sum alpha here, so this for any constant alpha. Okay, so this will be z a alpha of z of 1. Okay, or we can have the solution alpha multiplied z by z minus 1. Okay, so we got this result. Now let us see some of the exponential transforms here. Okay, so let us find the transform of e to the power of an and e to the power of minus an. Let us see this. Okay, first let us look at e to the power of an here. Okay, so we know the formula z of un is that is summation n is equal to 0 to infinity un z to the power of minus n, and now un as e to the power of an. Okay, so z of e to the power of an will be summation n is equal to 0 to infinity e to the power of an z to the power of minus n. Okay, now by substituting we have already obtained the result z of e to the power of n. right? So this is z by z minus a, right? So let us substitute that here. So this would be z by z minus e to the power of a. Okay, now when un is e to the power of minus an, okay, so z to the power of e to the power of minus an be z by z minus e to the power of minus a. So this is the solution. Yeah. Okay. Now, yeah. Now let us find the transform for for so cos h n theta, okay, and sin h n theta. All right, let's look at this now. Okay, so first let us write down what is cos h n theta. Okay, so that will be half of e to the power of n theta plus e to the power of minus n theta, and sine h n theta will be half e to the power of n theta minus e to the power of minus n theta. Okay, and now let us obtain this result first. Okay, so z of cos h n theta, okay, that will be z of half e to the power of n theta plus e to the power of minus n theta, right? Okay, so this is z. Let us take the constant outside. Now what here we are using is that is a linear property, taking out the constants out, and so half being the constant. Let us take that out. So we get half of z of okay, z of e to the power of n theta plus z of e to the power of minus n theta, right? Let us have, let us solve this now. Further, now this is half of z by z minus e to the power of theta plus z by z minus e to the power of minus theta. Okay, now further, solving this, we get half of let us take z as common here. Okay, c2, this will be z minus e to the power of minus theta plus z minus e to the power of theta by z minus e to the power of theta and z minus e to the power of minus theta, right? Now further, we know that e to the power of theta plus e to the power minus theta is 2 times or cos h theta, right? Yeah. Yeah. So let's substitute it. So taking, let us take that command here. So this is 2z minus e to the power of theta plus e to the power minus theta by this is z squared minus z into e to the power of theta plus e to the power minus theta plus 1. Okay, which can write this as z by 2, and this is 2z minus 2 cos h theta by this is z squared minus 2z cos h theta plus 1. So further we can remove cancel 2 here. So this would lead to z multiplied z minus 2 cos h theta by z square minus 2z cos h theta plus 1. Okay. And now let us look at z of sine h and theta. So z of half e to the power of n theta minus e to the power of minus n theta. Okay, so this is half of z of e to the power of n theta minus z of e to the power of minus n theta. Okay, this is half of z by z minus e to the power of theta minus z by z minus e to the power minus theta. Okay, close the brackets. Okay, again we have solved for sine cos h and theta. So let us take z as common. Okay, and z minus e to the power minus theta minus z, this would be plus e to the power of theta, all right, by this is z minus e to the power of theta and z minus e to the power minus theta, right? Okay, and further we get this as now we know what is sine h and theta. So that is z of half of e to the power of theta minus e to the power minus theta, okay, by z square minus z e to the power of theta minus e to the power minus theta plus 1. Okay, so this would lead to z sine h and theta by z squared minus 2z cos h and theta plus 1. Okay, so we got the results of cos h and theta, and as well as sine h and theta.